Hi, my name is Kumar Rajiv. I'm a software design engineer in Windows Driver Framework team in Microsoft. This democast is part of a series where I'll show you how to debug KMDF drivers using kernel debugger and familiarize you with KMDF debugger extension commands. KMDF provides a rich set of debugger commands using which you can not only explore everything about your driver but also about framework. In the previous part, I showed you how to dump information about KMDF drivers, such as list of KMDF drivers currently loaded, all WDF objects created by a particular driver, object hierarchy, and KMDF verifier information. In this part, I'll show you how to dump device instance specific information, such as PNP power state, PNP power callbacks, and S0 idle and SX wake related information. I'll also go through IO queues and WDF requests. Now, as I showed you before in the previous democast, you can dump all the device instance of a driver using bang WDF driver info command. So let's resume from there. OSR USBFX2 is the driver that I'll use in this demo. Let's get the list of all the drivers loaded first. Here you see OSR USBFX2 driver loaded. Let's use bang WDF driver info to get a list of all the device instances. So there is one device instance created for this driver. Now let's begin investigating this device instance. Without flags, this command gives you a summary of the state of the device. For example, it gives you all the WDM objects in the stack. In this case, this device object, this WDM device object belongs to this instance of WDF device, and this device object is the one attached below, and this is the PDO. It also gives you current PNP power state and gives you a default IO target. It also tells you about any pended PNP or power ERPs. Tells you whether this device is the power policy owner for the stack. Now this command takes a couple of flags. I find the most useful being FF, because it gives all the information that this command could provide. So let's use this flag. So the output starts from here. Well, actually from here. Now, apart from giving the summary information that we already got using the default command without any flags, this output gives you detailed information about the PNP state. So KMDF keeps a history of 8 previous states of PNP and power, and this is very helpful sometimes in debugging problems. One thing you'll observe here is that these state names are very descriptive, and you can make a good guess on the state of the device. For example, the current state is PNP started, and you can see the history through which this device went. Similarly for power and power policy. It also gives you idle state history. Now it gives you information about S0 idle policy settings as well. It tells you whether the device has configured S0 idle and whether it is enabled right now. The state of user control. This is the user control that you see in Device Manager in Power Management tab. It tells you whether this is enabled or not. It tells you whether it is capable for wake during S0 idle and whether USB selective suspend is being used right now. It also tells you the idle DX state and idle timeout. Now it gives you information about SX wake policy settings. SX wake is so basically the ability of device to wake the system from its SX state. It tells you whether it is configured and enabled and whether user control is enabled. It also tells you whether what is the state of device power when system goes into SX. SX is basically any non-S0 state, so S1, S2, S3, S4, S5. Now power capabilities, it gives you information about power capabilities and gives you a list of all the callbacks that have been set on this device instance. In this case, you see 3 callbacks have been set: D0 entry, D0 exit, and prepare hardware. It also gives you a list of all the child lists along with a hint to dump the child list, and gives you a summary of the device properties that have been set during initialization of the device instance. For example, IO type and synchronization scope and execution level. Now, once we have all the information about the device, let's say an app wants to send IO to this device. For that, it has to open a handle to the device. Now there is a command to dump all the handles as well, and it's called bang WDF open handles. It takes device instance as the argument. Let's copy this WDF device object. Now this tells you that there are one open handles. There is one open handle. And this driver did not opt for creating WDF file object. Also gives you synchronization scope and execution level information. Now once the app has open handles, it can send IO. Framework receives IO and creates a WDF request corresponding to the IO ERP, and either dispatches it to the driver or puts it in one of its queues. Now you can dump all of the IO queues that have been configured for this device using bang WDF device queues. It takes device handle as argument. Now as you can see here, the output has all the information about all the queues configured. So there are 4 queues that have been configured for this device instance, and you can see information about each queue. So the first queue here is a parallel queue. It's a default queue and it's power managed. Currently it's in power on state, and it can accept requests and it can also dispatch requests. This is the queue state. Also, it gives you information about the execution level and synchronization scope. It tells you 2 very important things about queue. Number of driver owned requests. This is the number of requests that framework has dispatched to the driver. And number of waiting requests. This is the number of requests that are still waiting with framework in one of the queues. This gives you information about the callback that has been set on this queue. In this case, it's EVT device IO control. Similarly, you will see information about each queue that has been configured. The second one is a sequential queue. The third one is also a sequential queue, and this is somewhat interesting because there are some requests sitting in the queue as well as that have been dispatched to the driver. So let's see this more closely. So this says number of driver owned requests is 1, which means framework has dispatched one request to the driver. So this request is owned by the driver. And number of waiting requests is 4, which means these 4 requests are sitting in framework queues. In this case, this queue. And the callbacks that have been set on this queue is IOWrite and IOStop. Now you can drill further into this driver by dumping this request. Again, cut and paste this command line, bang WDF request. And this gives you more information about the request itself. It also gives you a hint on using a WDM command, which is bang erp, to dump the underlying erp. It also gives you information about the system buffer and length and the corresponding bang WDF memory object. So here we go. So we get the output of bang erp. So this part concludes here. As you can see, KMDF has a very rich set of debugger commands, and it allows you to start from one command and take hints from the output of that command and drill further down. So this makes debugging comparatively easy, and you don't really have to remember or pick up pointers from one place another place. You already have the command line in the output, and all you have to do is cut and paste and then go deeper into investigation. Do look for other parts of this series to learn more about how to debug KMDF drivers. Thank you.